Hey everyone, thank you so much for coming. So if you all wouldn't mind humoring me for a minute, something I've been doing recently at talks is starting out with a total non sequitur and then leading right into the talk so that when they edit it and put it on YouTube or wherever they host it, it sounds like I was just in the middle of telling a story and they wonder, like, why was he talking about that? When in reality, I wasn't. But anyway, so if I just went straight into it, you'd be like, why did you just say that? That's really weird. So you'll still think that, but now you know why. And the conference organizers can freely cut this if they want, or if they want to keep it in, they can. So anyway, thanks for humoring me. I find it amusing. You can feel free not to. And that's when I learned never pick a fight with a mime, even if you think you're going to win. But, anyway, thank you all for coming. I really appreciate it, and thank you very much for the conference organizers who invited me. So today we're going to be talking about how do you scale security. To give you a brief overview of the talk, at first we're going to talk a little bit about Agile and DevOps background stuff, how do you get people on board, and then most of the talk is going to be focused on what are some tips and tricks that various companies are using today that they found useful in terms of scaling security. This is part in-person conversations I've had with friends and security engineers at a number of Bay Area companies, as well as information from various white papers, blog posts, talks, and things like that, sort of all aggregated together in one, hopefully so you can take some cool tricks and add them at your company. I'm also a bit selfish in giving this talk because I know that many of your companies probably do really interesting stuff, and I hope that after this talk you'll come up to me, or maybe tonight or tomorrow, and say, hey, my company does this stuff, and then we can have an awesome talk about it. Anyway, so let's get into it. So a little bit about me. I'm a security consultant and research director at NCC Group. If you're not familiar with what we do, we're basically do everything related to security. So we do penetration tests for web apps, mobile, network. We do hardware, crypto, threat modeling, basically anything. But I'm based out of the San Francisco office. So to get anyone to pay attention to me, I need to dress like this. Before that, I was a security engineer, and before that, I was a PhD student at the University of California, Davis, where I normally dressed like this. So just to get a little background, I'm sure most people are familiar with Agile and DevOps, but just to make sure we're on the same page. So there's a lot of nice things about Agile and DevOps. So rather than releasing quarterly, we're releasing daily or weekly. There's this concept of infrastructure as code where you have config management tools like Chef and Puppet. And there's a lot of benefits to this. You're empowering developers and ops. You can release new features quickly. If users either really like a feature or have a problem with it, you can change that quickly rather than waiting a quarter or a year. So generally, you can iterate rapidly, and there's all sorts of benefits to this. Unfortunately, it's also hard. It's hard to do, right? So in most organizations we work with and talk with, the ratio of developers to security is 50 to 1 or more. Often it's hundreds to 1. So at the rate of release of new code and just the sheer ratio of people, you just can't possibly review all the code. And at the same time, security can't be blockers. There's no gateway like in traditional waterfall SDLC processes. And oftentimes code's going from development to production in minutes or days, not months. So one person, Tom Daniels, wrote a nice blog post. He's a security engineer at Square that I thought captured this nicely. Square has grown dramatically in the number of services we offer, as well as the size of the engineering team. So it became obvious that manually testing and monitoring everything is just not possible. So a big focus of their team has been scaling security to support the engineering team as much as possible. And I thought this was a nice way to sum it up. So as we work with a number of different Bay Area companies, and one thing I hear again and again from many, many companies is just fundamentally, how do you scale security? And I think there are a lot of answers. But from what I've seen, you can boil a lot of it down into two things, which we're going to talk in a lot of detail for the rest of the talk. But basically, you can create libraries and systems that make it easy to do the right thing securely. And then you can add automated, that is static and or dynamic checks at key points in the SDLC. And we're going to talk about that in a lot of detail soon. And again, where am I getting all of this stuff? So this is things I've seen firsthand working with a number of Bay Area companies and talking with friends and colleagues, as well as pulling from just, what are people talking about in blog posts, conference talks, white papers, and so forth. So why automate? I think pretty much everyone here is probably on board, but just in case someone has some lingering doubts, security people are expensive, and they're also hard to hire. right? So automation can help your security team scale to get more done with the same number of people. And ideally, also, you're freeing up security engineer time to tackle more interesting, higher ROI tasks rather than doing something very boring and repetitive that is not a good use of their time. So this talk is aimed at a lot of different people. So for CISOs and security managers, hopefully here are some approaches and some mindsets that give you some measurable security things you can do to improve your organization, and also hopefully a little bit of motivation. So if you're not currently implementing security automation, hopefully it's a gentle nudge that, here's some nice benefits. And then for security engineers, here's some cool stuff that other people are doing. Consider using them. If they work in your org, feel free to use them. If they don't, then don't. And so how do you get people to buy in? So even if you have the best ideas in the world, fundamentally you need people to agree to actually do them. And this is probably worthy of its own talk in itself, but I just wanted to briefly talk about it. So let's say you want to get security management on board. You can pitch it sort of from the cost savings point of view. Hey, we can do more with the same headcount. We can scale the security team as the dev team is growing rapidly, as often is the case with startups. And generally, just we need to maintain the security baseline, a security standard across what we have now and what we're building in the future. For security engineers, hey, let's automate the boring things. Let's spend time on higher leverage, more interesting problems. And as much as security engineers like working 24/7, probably they don't. So let's protect their work-life balance as well. I think with security automation, oftentimes the security team and security management is on board, and you really need developers to get on board as well. So some specific things that might be useful to keep in mind are developers are paid to get features done and to add new things. They're not necessarily paid specifically to be secured directly. So keep this in mind. In any new security processes, you need to basically add low to no additional friction for developers. So make things more secure, but add as little friction as possible in practice. So if you have any alerts or tools that are going directly to developers, the false positive rate needs to be about 0%, depending on the organization, in terms of getting people to actually listen to you over time. And there's a number of things you can do to make new standards and processes as easy to adopt as possible. So for example, if you have a secure wrapper for a library, make it have the same arguments and the same everything so that you just change the class name and boom, you're done. Another thing is maybe try building in some stuff that the development team wants. For example, telemetry. If you have some wrapper library that has some nice security benefits as well, maybe also have that library have maybe some this is how long this segment of code takes to run, or here's some telemetry that talks back to both something the security team as well as the development team can access so that they can understand how it's being used in production. We're going to talk about some specific examples of that soon. And then one thing we've also found is finding and fixing bugs is often viewed positively by developers for improving robustness and code quality, which is something, unless they're thinking about security, speaks directly to what they're concerned with. Okay, so we've been blazing through the agenda, which you haven't seen yet, but we talked about me, some Agile stuff, some very context-appropriate memes, and we've also talked about sort of the why and who is getting involved in scaling security. And the rest of this talk is going to be specifically focusing on the important stuff, the how. So specifically, here's a few disclaimers before we get into it. I'm going to reference several tools and products. This isn't an endorsement. It's just to make things concrete. And we're going to describe specifically how a number of companies are doing things. And these aren't necessarily the best or the only way. It's just some ways that some companies have found it to be useful. So if it doesn't make sense for your company and your culture, either don't do it or maybe change it so that it does make sense for your company. And again, I can't cover everything important in SecDevOps in 50 minutes. So there's a lot of stuff I'm not going to talk about. And a lot of stuff, obviously, that you all know that I probably don't know that hopefully we'll talk about after. So at a big picture, we're going to talk about a couple of main points to add various security processes or security efforts. So one is with security engineering in terms of building libraries that help do the secure thing by default and very easily for developers. Then we're going to talk about things that you can implement on developers' laptops as well as integrated with code hosting. There's many things you can do, but we're going to focus on static analysis here. And then what are you doing in sort of the test and QA environment? We're going to talk about some dynamic analysis and fuzzing. And then finally, in production, we're going to talk a little bit about monitoring. But as a whole, this talk is focusing more on AppSec than the infrastructure stuff, just to give you a heads up. All right, so let's talk about some high ROI security engineering tasks. So I've talked with security engineers at many different companies, and one thing they consistently state is that one of the biggest ROI things they've done is building libraries or tools that are secure by default for use by the development team. And if we look back in time a little bit, back to web frameworks maybe 5, 7 years ago, many of them didn't output encode correctly by default. You had to add, for example, in Rails, earlier versions, you had to add H in order to properly output encode something. As a result, because you had to do something for it to be secure, cross-site scripting was much more prevalent. Now, Rails output encodes by default, so you need to specifically do something insecure to make it vulnerable. And so this idea of you having to do something extra to make it not safe is sort of the crux of this idea. So basically anything related to managing secrets, anything related to crypto, authentication, authorization, SQL, file system access, shell exec, etc. These are the types of things that might be interesting for you to consider. One company has this, they basically banned the use of MD5 in their code base, and instead they wrote a simple wrapper called non-cryptographically secure MD5, which just calls MD5. But the idea is by you. Yeah, so it does the same thing, but the idea is when you use something like this, you're explicitly acknowledging as a developer, hey, I am using this, but I acknowledge that I am not using the MD5 and relying on its cryptographic randomness. Like, it's okay, I just sort of need kind of like something that represents this file or string or something like that. So let's talk about some specific examples from companies. This one I think is particularly cool. So this company has a test case that runs both locally on developers' machines as well as in integration tests that essentially automatically checks if a controller method is missing access controls. So basically how it works is when the test runs, it does like rails.routes and programmatically iterates through all controller methods that have been registered and looks inspects that code itself to say, is this specific access control method being called at all? So you don't actually ahead of time need to say what are all the controller methods, because obviously when Rails is running, it can infer like what are all the routes. So basically if a developer adds a new controller method but doesn't do any access control checks, this will automatically flag that in the test suite without any additional manual work by the security team. And they said this has caught a number of things where the developer was adding a new endpoint and they're like, oh, I didn't know I had to do that. And I thought this was a really cool idea. Another example is one company has a very battle-tested Vue library that once they built it and forced everyone to use it, basically they haven't had cross-site scripting in a couple of years. Another company has a data model wrapper library that if you're going to access user data, if you're going to talk to the database, you have to use sort of this battle-tested thing. And since they made everyone use this, they haven't had SQL injection at all, and they said 3 or 4 years. So some big wins here by putting in some upfront work. The core takeaway of this is basically, if there's something that's hard to do securely, if you have to be aware of this threat or that threat, just build a secure by default implementation and then make people use it. And ideally, it's easy to use and well documented so that that's not a big ask. OK, cool. So now we're going to talk about what you can do on a developer's machine. But before we get into static and dynamic analysis, just to make sure we're on the same page, I wanted to take you to a quick diversion. OK, so just so we're on the same page, so static analysis is basically reasoning about code from looking at it, not running it. And then dynamic analysis is running code and observing how it behaves. There's like a lot of details, but at its core, that's all it is. And there's some fundamental trade-offs here. Static analysis tends to be high coverage in that you can look at all of the code at once, but it's imprecise in that there's false positives. While dynamic analysis, it can be hard to get good code coverage, like make sure you exercise all the functionality, but it's precise in that when it finds something, it's probably a true positive, though not always. And also there's a range of complexity of tools, right? So simplistically for static analysis, you have things like grep and linters, and then you have more complex things like fortify and check marks. And similarly, on the dynamic analysis side, you have intercepting proxies like Z-attack proxy and burp suite, and then you have more complex stuff that is more automated. So I talked with a number of different security engineers at various companies, and this was pretty much the first thing everyone said. And I think that that's really sad because I personally like static analysis a lot, and I think it's great. But I think the challenge is people think oh, static analysis is awesome. There's all this promise. I'm going to integrate it. Then we're going to find all the bugs, and it's going to be, this perfect happy place. But then they run it for the first time. At least many of these static analysis tools, and then it's like that because there's a lot of false positives. So what I would encourage you to think about is static analysis isn't a binary, you're either doing it or you're not doing it. There's actually many different types of static analysis in terms of how complex it is and how much knowledge essentially it has over what it's analyzing. So just quickly, I wanted to talk about that a little bit. So on this most simplistic end, you have grep, which is your analysis is very localized. It's not syntax aware. It doesn't sort of understand the programming language it's looking at. And you're looking with essentially regexes or regular expressions. Then when you move a little bit more complex, you have something that's doing like lint or abstract syntax tree matching, where you are syntax aware, you have some understanding of language semantics, and you can express rules using code constructs. So for example, using AST matching, you could say, match all conditionals who one of the predicates has like arithmetic multiplication in it or something like that. Something that would be very annoying to build with grep, and it would be like 2 lines of monstrosity. And then finally, at the other end, you have commercial static analysis tools, which build a very detailed model of code. And the rules you can write are very complex that can convey control or data flow through the application. So the reason I'm talking about this and taking time to talk about it is a lot of people, again, say like, oh, static analysis is blanket terrible, but there's actually many wins you can get sort of earlier on without necessarily going all the way to the most complex stuff. And we'll talk about the complex stuff as well soon. So each of these have strengths and contexts in which they're useful is sort of the main takeaway for this. OK, so let's get back to it. So what can we run on developers' machines? So if you're running something on developers' machines, this needs to be very fast and have low to no false positives. Otherwise, people generally aren't going to be on board. So some ways you could do this are by implementing Git hooks or maybe even as a part of the test suite. So these are some examples based on various companies I've spoken with. So one company rejects all database accesses that don't use, again, as mentioned before, the approved API. Another rejects all SQL that looks like it's concatenating strings. Again, this is sort of a regular expression. Another says, hey, these are some known dangerous functions that, depending on the code base, we just don't want them in there at all. For example, shell execing or something like that. So one company in particular uses ESLint, which is basically a linter for JavaScript that checks for any uses of eval or new function in a Node.js application. So basically, the test suite makes sure that these common ways that if they were used dangerously could result in code execution on the server, they just block those very early on in the process. And again, you could also reject commits that seem like they're adding secrets, like AWS or other API keys or credentials and things like that. And again, what I wanted to point out here is all of these are essentially greps, right? But at the same time, it yields some nice security wins. So if you have 1,000 developers committing once or twice a day and you have 3 security engineers, you can't really look at all of that at all. But you could, say, block the bad stuff. And we'll talk about some more nuanced stuff in a second. But here's some examples. There's many other things that if you think about it, probably you could do as well. OK, so let's talk about code hosting. So here, the developer has pushed something into, say, GitHub, GitLab, Bitbucket, Jenkins, just wherever you're hosting code. And this could be implemented in on-receive hooks or new branch creation or things like that. And we're going to talk about 4 different things you can do. And there's many others that you could do, but we're going to focus on these. So blocking banned or dangerous functions, detecting security-relevant code additions, alerting on sensitive file changes, or looking for out-of-date dependencies. Let's see. So this is essentially the same checks that we just talked about running on developers' machines. You probably also want to implement it in the code hosting as well, because the developer may not have their laptop set up so that it's properly enforced. And basically, you want something that is definitely going to check it, and you're not relying on every single person being properly configured for those checks to happen. But to give you one specific example of something that I think is neat, one company is using this idea to gradually improve code quality over time by blocking new additions of anti-patterns. Like, hey, we don't want this anymore. We have a bunch of it already, but let's block it from getting worse. So specifically, they're trying to migrate to a strict content security policy, but they have inline JavaScript everywhere, right? So they could start sending a bunch of pull requests in, like fixing a bunch of them manually, but at the same time, there's more developers than there are security people, so they're probably going to push more of it than they're fixing. So the idea is, okay, let's block new additions of inline JavaScript, and then once we've done that, we can gradually refactor existing code such that we're removing what's there, and then gradually we can have a stronger content security policy. Okay, so there's probably parts of many code bases where oh, no, that's the next one. So oftentimes there's interesting primitives that you might not necessarily want to block outright, but you might want to start a conversation with the security team. So for example, if someone pushes new code where they're adding some crypto-related things like hashing, encryption, or file system operations, things like that, maybe you don't want to block it, but you want to start a conversation saying like, hey, I see you're doing this. Like, do you need to be doing that? Or what exactly is the context you're doing here? And what's nice about this is you're not a gateway. You're not blocking people from push new code, but you are automatically getting some context about how applications are evolving and maybe where some code hotspots are. You can also correct common errors early. So maybe someone is using a hashing function like a bcrypt or something like that. They're like, oh, this is a safe hashing function. But because you started a dialogue, you might find out, oh, this developer should probably encrypt the data rather than hashing. So one specific example is a company has set up some hooks so that when people push code, it checks for a couple of these sort of interesting functions and then sends a Slack message to a private channel that the security team is in so that they can say, you know, this developer in this repo, in this commit, pushed code that contains these interesting functions. And the security team at their leisure can sort of review these and start conversations with the developer. Again, they're getting insight into what's happening in many code bases without much sort of hands-on manual time. All right, so in many code bases, there are specific files that are very security relevant that you probably want to know when they're changing. So for example, code that is implementing authorization or authentication, sessions management, encryption, stuff like that, things that basically you think, if someone touches this, I probably want to know. And this is actually pretty simple to implement. So if you just simply hash the files and then alert when their hash changes, you can implement a similar thing that we just mentioned in the last slide where, you know, okay, these are the files I care about. If they change, maybe send me a Slack message or email me or anything like that. If you wanted to take this a little bit further, you could say maybe we only allow the security team or specific senior developers to modify critical files and, you know, let me know if anyone else does. Or maybe you could build a model of which developers work on which parts of the code bases, or even which code bases. And you could say, okay, Joe normally works on this, and Alice normally works on this, but now we see Joe touching some totally other part of the code that he's never touched before. And maybe we want to pay more attention there because he has less context and domain knowledge in that software repo. So maybe he's more likely to introduce bugs because he doesn't normally edit there. And then Square, in the blog post I mentioned before, talks about they also leverage code churn and code quality metrics for where to focus their engineering time, which I thought was a smart idea as well. All right, so lastly, you can keep track of dependencies. So generally, it's useful to keep track of, you know, what are all the dependencies we're using? Are they out of date? Do they have any known vulnerabilities? If they do, how severe are they? And ideally, as an organization, you set a policy for, you know, how quickly do we update something based on how out of date it is by time or severity and things like that. So one company has a pretty interesting process where essentially when any developer adds a new dependency to the repo, they automatically calculate a bunch of metrics about it, generally to determine how trustworthy is this new addition. So specifically, when someone adds a new repo, so for example, if this was, say, a Node.js project, they would automatically hit the NPM registry and say, okay, how many downloads has this had in the last month? What about lifetime downloads? Because if it has, say, 10 downloads ever, maybe not very trustworthy, while if it's had hundreds of thousands, it's more likely to be trustworthy. It might be malicious, but it's perhaps less likely. And you can also apply some of the similar techniques about you have lists of dangerous functions, then you already have, say, greps or other tooling to find them. You could also run that on all your dependencies to say, hey, you just added a new library, and it's like shell execing stuff everywhere. So maybe let's look at that and see, you know, are you adding something that likely has a very impactful attack surface? So with a number of these things, it's basically been very useful to say, oh, given new code, let's do something. Let's run some arbitrary check. And because this is a common desire, there's at least 2 tools, probably more, that I'm aware of that essentially let you do this fairly easily. So you can hook it up to different Git repos and say, hey, whenever someone pushes a new branch, run this check or do this dynamic analysis check or things like that. Let's see. So a question I get asked a lot is, should I buy a commercial heavyweight static analysis tool? And these are, again, generally ran daily or weekly because they take hours to days on complex code bases. And I don't think there's a simple answer. I think that it can be helpful in many cases, and in others less so. So I'm hoping to provide at least a very small glimpse into maybe some factors that you should consider when making that decision, but ultimately it's up to what technologies does your company use, what's the development processes like, what's the culture like, and so forth. So for example, something you may want to ask yourself is, do we have a lot of large legacy code bases that haven't been thoroughly vetted? If you do, then perhaps something that can give you quick, high-level coverage over a lot of things may be useful. Is a lot of your code in C or C++ and Java? I think, in my opinion, static analysis tools probably do a bit better job on the statically typed languages than, say, Python, Ruby, and JavaScript, which dynamic languages are just fundamentally very hard for static analysis. And there's reasons I'm not going to talk about, but feel free to chat with me later about it. How mature is your security program? Do you have a very well-vetted, well-funded group that's been doing great work for years, or are you the first person? And if so, maybe getting some extra help is nice. Another challenge many companies have is if you use a lot of custom frameworks that are not popular or that are just only in-house, oftentimes they have non-standard control flow. So if it's a custom web app framework, how do you define routes, and how does control sort of flow through the program? So if you're doing non-standard things, you will essentially need to teach the tool how execution flows through your program in order to get useful results. And then in many cases, what this all comes down to is, are you willing to invest probably months of security engineer time on the rollout in terms of adding it to a new code base, whitelisting all the false positives, tuning it, adding custom rules, and things like that. So if you want to just run it once and then forget it, this may not be the best approach, at least based on what I've seen. So just a little bit more. I would encourage you, and again, I'm not saying you should or you shouldn't buy it, because I think it depends on the organization, but I would encourage you to calculate the ROI in terms of how much security engineer time is going to take to comb through the results versus how many bugs of what severity do we find. If you find that it takes weeks and weeks of security engineer time to find mediocre bugs, then probably you should just have them do manual pen tests, or maybe build your own tools, or just hire pen testers or things like that. Is it going to be a large upfront time investment, but maybe low recurring time cost, or is it going to be continuously high time cost? Because those, it isn't just the sticker price of the tool, right? It takes maybe half of a head count for a whole year, and we pay them X amount of dollars. So really, it's the amount of the tool plus the security engineer time, right? And sometimes maybe you'll find a bunch of good bugs when you initially roll out, but as you get better as a development organization over time, perhaps you're just aware of the types of flaws that your code bases tend to have, so then you have less of them. Anyway, these are just things to think about. We have seen a number of companies have started either building their own tools or writing custom rules for the existing tools, and we'll talk about that more soon. Okay, cool. So let's get into some test and QA environment stuff. So similar to static analysis tools having trouble on huge modern code bases, similarly, many commercial dynamic analysis tools have trouble on very JavaScript-heavy apps, and apps with many multi-step flows and things like that. This talk from AppSec USA in 2017, which you can just find on YouTube, about 2/3 of the way in the talk, he does go through, I think, 10 to 15 different reasons why fundamentally totally standalone dynamic analysis is hard. So I would encourage you to look there for a few more details. But there are a couple of approaches that do add value in practice. You can ensure a security baseline for new services or existing ones. You can test for regressions, and then you can also do some automated fuzzing. So let's talk about those. All right, so maybe you don't have a totally awesome dynamic analysis tool that can do everything and find every possible bug, but maybe it can find some nice security baseline. So let's say the security team sets certain security policies, such as every service must communicate over TLS and they must use strong ciphers. Or every service needs to have a very strict content security policy, or all cookies need to have the secure and HTTP only flags, things like that. So none of those checks require significant domain knowledge of the application. They're sort of pretty easy, high-level things to check. A couple of companies, Mozilla, for example, for one, has a talk that I've linked there, where essentially any new service that's rolled out at Mozilla, at least at the time of this talk, is essentially automatically scanned for various best practice things like these. I think they configure a sort of minimal Z attack proxy scan that'll just auto-run on everything they deploy to find low-hanging fruit. All right, so one thing that I think can be quite useful is for each vulnerability you learn about, whether it's via a pen test or a bug bounty or found by an internal team, add a unit test that tests that exact issue with an example payload. So let's say you had cross-site scripting in this endpoint with this URL parameter. Just add a unit test that has script alert 1 that will work in that current case, so that code is changing quickly. Maybe you added a fix or added protection, but things get re-architected and accidentally this fix is rolled back. So by doing this, you're essentially inoculating yourself against all bugs you've ever seen before in the code base to make sure they don't come back. And this was called out by Zane Lackey in his Black Hat talk last year, which I would really encourage you to watch. This is on YouTube, but he does a really nice job about laying out, here's how you should think about it, here's how things are shifting from waterfall to DevOps, and generally it's one of the best talks I've seen on SecDevOps, period. So I would really encourage you to check it out. It definitely influenced my talk a lot. All right, so let's talk about a case study. So here, the background is NCC Group was brought in by a company to integrate some automatic fuzzing into their SDLC. Specifically, if you want to know a bit about sort of the scope of work, I think this was one person over 4 weeks that did this. So the company had several native services written in C that were parsing input from the internet, and I think it had some internal services as well, parsing things like WebSocket traffic, JSON, stuff like that. The company pushed to production about every 2 days for these services, and they had very high uptime requirements. So these services processed billions of messages a day. So when we came in, there were a couple of challenges. The code was tightly coupled. That is, it was non-trivial to write good test harnesses. And when I say test harnesses, what I mean is, in the context of fuzzing, a test harness is essentially a test case designed to specifically exercise some sort of functional block of the application. So one input is unlikely to be able to test all of an application, but if you say, okay, there's 5 core parts of this application, let's write a test harness such that the input gets the fuzzer into this main code path and sort of goes through all of that, so then we can sort of iterate and get good coverage that way. So another challenge was the release pace was limited because, again, we had sort of 2 days for a given build. And we also had to scale the fuzzing process across a cluster of machines with many different test harnesses. Okay, so let's talk a little bit about what we did. So we wrote, the fuzzer we used was AFL, or American Fuzzy Lop. And we wrote, I think, about 12 harnesses in total for different functional areas of the program to get good coverage. We then set up a fuzzing cluster that continuously fuzzed new builds based on priority metrics. So the priority metrics are probably different company to company, but you could imagine, these, say, externally facing services, probably we should prioritize more than things that are only internally facing, as the risk is lower. We then made a table for the development team that basically said, if you update the code manipulating this structure or working on this functional part of the code, run this test harness. So it was essentially a mapping between, if you change this, run this test harness to make it very clear. We also created some automated detection such that when there was a crash, we would auto-create a JIRA ticket with what input caused it. Here's the stack trace. Here's all the information you have about why it crashed. And then we would assign that to the project owner. So continuously over time, project managers are just getting JIRA tickets saying, hey, this thing you're in charge of crashed. Here's what crashed it. Here is all the information we can provide you about what's happening, which is sort of running on its own, which is pretty neat. So we learned a couple of lessons. A couple I'll mention are, there needs to be a constant dialogue between the security and development team. I think in many organizations they are separate teams and they talk every once in a while, but it really helps a lot for them to either have a security person embedded in the development team or just work together very closely, because the structure of the code can make fuzzing either a lot easier or a lot harder. So specifically working with the development team to make sure the code exposes a clean API can make it very easy to write test harnesses. And there's also nice benefits from the developer side for making a clean API in terms of code maintainability and readability. And one interesting outcome was the development team really appreciated the bugs, not just for the security implications, but for improving robustness. Again, these are services processing 2 billion messages a day, very high uptime requirements. So I think in the first 2 or 3 days we started fuzzing, we ended up finding 13 to 15 unique crashes, which we then told them. So these bugs had not been found by any of their manual testing or manual code review. But they were very excited, even if they weren't exploitable, because they were like, "Hey, this is, this is making our program more robust and able to process even more things, longer uptime." So as with anything, even when it's successful, there's a lot of open problems. The first one is very common to pretty much any fuzzing attempt. How long do you fuzz? Because in theory, you could just fuzz forever, right? So currently, I think at the end, we were mostly just fuzzing a set amount of time. So we have, say, 2 weeks before the next release. So we'll fuzz for 2 days until the next release. So we'll fuzz until it's time. But ideally, you have some other metrics in terms of, we're monitoring, are we hitting new code paths? And then once we sort of hit a plateau in terms of we're not getting any new code coverage, probably we can stop because we're just spinning cycles. Another interesting thing is it possible to only fuzz the newly modified code? So say there's 10 core areas of the application and this new build only changed one of them. Why waste cycles testing the other 9? Because nothing's changed. And we have enabled them to do that sort of manually by giving them this mapping of functional areas to test harnesses. But if we were able to sort of manually like auto diff, these parts of the code have changed. We know this part of the code is in this functional area, so run that test harness. I think that's something that's feasible. We just didn't have time in the scope of the assessment to do it. But I think that's a very interesting problem that if you have some insights into, I'd love to chat about it. And again, so I'm the one talking about it, but really all credit for this work goes to my colleagues, Ryan Sullivan and Gabe Pike. So we've talked about a bunch of different things, but let's discuss a little bit, say there's some challenges with these commercial tools. Maybe we want to roll something in-house. What are some things we want to consider? So there's a lot of things to consider. So doing this well and safely is important to consider. So I would encourage you, rather than trying to build a tool or use a tool that finds every bug class, for example, cross-site scripting, SQL injection, et cetera, like everything all in one, perhaps instead focus on finding one class of vulnerability very well. And a lot of companies think, okay, let's start at whatever is the most severe issue, like code injection, remote code execution, and then we'll go backwards. But instead of focusing just on the severity, I would encourage you instead to focus on a combination of the severity as well as precision. So even if an issue isn't very severe, maybe it's just open redirect or something like that, but if you can build a tool that finds it with essentially 0 false positives, just build that tool and then run it and sort of auto push all the findings to developers, and you've essentially like wiped out this class of issues because you have such good precision. And then sort of like with vaccines and herd immunity, you can then take that time that you would have spent on these issues and then move to the next thing and then solve the next bug class and the next bug class, et cetera. So basically think of, what are issues that are reasonably severe or maybe even not, but I can find very precisely. And then maybe you end up having a collection of tools that each do one part very well. And again, by having tools that give very high signal actionable results to the dev team, you're building trust. So they're more likely to want new things from you and willing to continue working with you. So a quick case study. This is a large software company with tens to hundreds of thousands of internal services and, a finite number of security team. What they did, they attack one class of bugs at a time. They focused on checks that were low to no false positives at all. And one unique trick that I think is interesting is they actually have a system such that if they add a new check and too many of their there's too many false positives for this newly added check, they actually automatically disable it so that it's not run on anything new. So over time, only the high signal checks are kept in. And I thought that was a nice way to do it. Okay, we have been sprinting through, and let's talk about monitoring. But quickly, some infrastructure best practices. So we see this pretty commonly in many organizations. So there's this idea of infrastructure as code. So servers are generally configured with something like Puppet, Chef, or Terraform, which makes the configuration of servers declarative and reproducible, and also versioned in source controls. So you can see how it changes over time. And for many of these companies, if someone SSHs into a server or somehow the server gets in an unclean, non-default state, they just wipe it and then reprovision so that everything is in the expected state all the time. A number of companies are also managing secrets, either with their config management or a separate secret service. Puppet and Chef have built-in ways to do that. HashiCorp has a secret as a service open source tool you can use called Vault. And if you haven't heard of it, there's a tool called GitRob, which I encourage you to play around with. It's pretty fun. What it does is essentially you pass in a GitHub username or a GitHub organization name. And then what it does is it clones all of the repos associated with your targets and then looks for secrets inside of it. So this is a good way to get an idea for your organization's open source footprint pretty easily. So on an engagement with a client in the Bay Area, I ran this on the organization, and I ended up finding that one of the developers for that organization had in their bashrc file a link to the stand-up URL to join their weekly developer stand-up. And so that URL had the unique token needed to join the stand-up. So unfortunately, it was a web application test and not a red team, because otherwise I could have, I'll listen into their calls for a few weeks and gain like sensitive information. So unfortunately, I wasn't able to do that. It was just like a web app pen test. But it gives you a flavor of the types of things you may be exposing that you don't even know about. And so finally, this is not necessarily widely used for companies, but a couple of them are talking about it is having mutual TLS between internal services. So not just talking over an encrypted channel, but also having some guarantees about, okay, I'm this service, and I know that these other services are supposed to talk to me, and I don't let other people, because you can verify sort of the client certificate that they present. So this is a nice way to also sort of enforce access controls. So I'm going to quickly talk about some neat tools, both of them by Netflix. So RepoKid is basically new applications at Netflix are automatically granted a base set of AWS permissions. And what RepoKid does is whenever a new service is launched, it watches it for a little while and says, okay, what API calls are you making? How are you working? And over time, it'll say, oh, you have this permission, but I don't think you need it. So it'll programmatically remove it and then observe the application to see if it starts failing. So if it doesn't, then like, oh, you never needed this permission. Now you're more secure because if someone were to compromise that service, you can only do the remaining permissions worth of things. But if the application starts failing, they just automatically roll that back and give the permission back. So what I think is really cool about this is applications are eventually reaching this steady state of least privilege with minimal to no security team interaction. So AWS has a lot of permissions, right? And it's pretty complex. And personally, I don't think it's fair to expect every developer to understand everything about all of AWS's permissions. While at the same time, the security engineering team doesn't have the bandwidth to talk with every developer who's releasing a new service, right? If they did that, then they would never spend their time doing anything else. So this is a nice way to let developers go forward and build what they want to build, while at the same time, with minimal to even no security team interaction, all of the apps that are being released are gradually becoming sort of a steady state of least privilege. So I think this is a really cool idea, and I think that it can be applied in other places that we haven't seen yet. And the second one is Chaos Monkey. I think most people have heard about this, but just to quickly mention it, basically they force developers to build robust apps from the beginning by randomly shutting off AWS instances of a given service. And what I think what's nice about this is to sort of step back for a second and think like, what's the principle here? I think a lot of times security comes from the point of view of developers spend a lot of time building something, and then we come at the last minute and say, hey, actually, you need to also make it secure. It needs to do this, and adds all these requirements sort of after they've already done all the work. And at that point, it's a lot of extra effort for them to change it. But by making expectations explicit and also enforced programmatically as soon as the development process is possible, it makes it be a lot less work because it's just an expectation from the beginning. OK, last things. So what are some ideas for detecting attacks in production? One idea some companies are doing is having the idea of canaries. So on servers or laptops, having things that look very juicy and exciting to attackers, such as AWS access tokens, files that look like they have credit cards, things like that. But essentially having monitoring in place such that if anyone ever touches those, alert. Similarly on websites, for login pages or company logos, a number of companies have some extra like HTML and CSS and JavaScript such that if someone were to copy that directly and put it on a separate phishing page, it actually sends some subtle telemetry back to the company saying, hey, someone is copying your login page. It's running on this IP address on this host. And essentially, you can sort of see in real time if someone isn't careful about setting up a phishing site for your page. And they have caught people doing that in practice. So I think that's pretty neat. And then finally, there's this Canary token site. I haven't used it, but I hear good things. It sort of generates new Canary tokens that you can place, and it'll tell you when they're used. So next idea, overriding the runtime environment to detect code injection. So if you think about cross-site scripting, what is it? It's you're inserting JavaScript that's being executed, so sort of a code injection of JavaScript. So one company realized they looked at all their front-end code and said, oh, we don't actually use alert anywhere on purpose. So essentially what their JavaScript does is they override the alert method such that if any attacker puts in a cross-site scripting payload before the alert box comes out, instead it sends a very subtle, innocuous looking telemetry back to the security team server and says, hey, this user, this page, this parameter, or this IP address was just successfully able to run JavaScript. You should probably take a look at it. And then after it does that, it then shows the alert box. So unless the attacker is very cognizant about all the different network requests, the observable behavior to them is the same. So they actually said they had a bug bounty security researcher find a cross-site scripting vulnerability on one of their sites, and they saw it immediately, and they actually patched it before the person filed the bug bounty. Yeah, I think they still paid it out because they were nice. And Zane Lackey also talks about this when he was at Etsy, but this was a different company. So similarly, if you're writing code in dynamic languages like Ruby or Python, and you're writing a microservice that doesn't need to write to the file system, maybe overwrite the file write method such that if someone tries to write to the file system, again, send telemetry back to your server, the security team server, and then raise an exception or maybe fail silently, things like that. Again, a company wrote an XML parser to make it very safe and not vulnerable to XXE. And they did that by making it a drop-in replacement, so it had the same function signature. And again, it provided something the developers wanted, which is telemetry. And then finally, a number of security tools have tool-specific user agents if you don't configure it. So SQL map, for example, if you don't specify the user agent flag, will say it's SQL map. So you could configure web application server to say, hey, this known security tool user agent is browsing our site. Probably it's someone testing us, right? And you could also look for references to Burp Collaborator and so forth. All right, so 2 things before questions. So I'm attempting to build a best practices sort of pro tips playbook about all these things and a couple more that I didn't have time to talk about. So I would love to hear anything neat that your company is doing. I think a lot of everything I've mentioned today has basically been a result of conversations with various people. So I'd love to hear what you have to say. And also, I'm starting to build some tooling that's aimed at making writing custom static analysis checks easier. So if you have like, oh man, I really wish I had something that did this, please let me know. But yeah, that's all I have. Thank you very much for your time. Yeah, I might have time for like 1 or 1.5 questions. Yeah. Great.
Great presentation, thank you.
Yeah, thank you.
Have you talked to folks that are trying to do the kind of like the code analysis problem, the whole spectrum for a very polyglot environment? Like, how are they doing that?
Yeah, so the question is anyone trying to roll static analysis out to a polyglot environment where many languages are present? Yeah, so there's a couple of different ways you can do that. Some commercial tools support many languages to varying successes, I think, in practice. And then if you're building tooling that's, say, black box web app testing, then you don't necessarily care about the underlying languages. But yeah, I think that's a mediocre answer. But yeah, I guess that's all I've seen personally. But yeah, let's chat more about it. All right, with that elegant herald, yeah, feel free to come up and let's chat. Thanks for your time.